let us understand angular velocity and their relation with linear velocity. Every particle of a body moves in a circle, which lies in a plane perpendicular to axis and has its center on the axis. Suppose the particle at P has velocity v along the tangent at P. Let P dash be the position of particle after time delta t. The angle PCP dash, that is delta theta, describes the angular displacement. Average angular velocity equals to delta theta upon delta t. As delta t tends to 0, the ratio delta theta upon delta t approaches a limit, which is instantaneous angular velocity d theta by dt, denoted by omega. Instantaneous velocity omega equals to d theta by dt. The linear velocity, the angular velocity and the radius are related by simple equation v equals to omega r. This relation applies to all particles of a rigid body at any instant. Thus, for a particle at particular distance ri from the fixed axis, the linear velocity at a given instant vi is given as vi equals to omega ri, where index I runs from 1 to n, where n is the total number of particles of the body. For particle on the axis r equals to 0 and hence v equals to 0. Thus, particle on the axis are stationary. Text. We have characterized pure translational of a body by all parts of body having same velocity at any instant of time. Similarly, we have characterized pure rotation by all parts of body having same angular velocity at any instant of time. Angular velocity is a vector that lies along the axis of rotation and its direction is according to right-hand screw rule. Suppose a disk is rotating about the axis passing through its center. The direction of angular velocity omega will be governed by right-hand thumb rule. If the disk is rotating in opposite direction, the direction of omega will be governed by right-hand thumb rule. We will now look at what the vector product omega cross r corresponds to. Suppose a rigid body disk is rotating about the axis passing through its center. Take a point P on the rigid body whose position vector r equals to OP. Now omega cross r equals to omega cross OP, where OP equals to OC plus CP. Thus, omega cross r equals to omega cross OC plus CP. Key point: OP, OC and CP are the vectors having the following rules of addition, according to which OP equals to OC plus CP. On solving further, we get omega cross OC plus omega cross CP, but omega cross OC equals to 0 as they are along the same line, that is OC. Hence, omega cross r equals to omega cross CP. Also, modulus of omega cross CP equals to omega CP as theta equals to 90 degree. CP equals to r perpendicular, so omega cross CP equals to omega r perpendicular. But the linear velocity vector v at point P has same magnitude and direction. Thus, v equals to omega cross r, where omega is the angular velocity and r is the perpendicular distance of the particle from the axis of rotation, and the direction of velocity is tangential to the circle described by that particle. Now, let us understand angular acceleration. Angular acceleration alpha is the rate of change of angular velocity. Suppose a stone is rotating tied with the string. The stone is rotated with a non-uniform speed. The magnitude of velocity v keeps on changing, and so the magnitude of angular velocity omega also changes. The rate of change of angular velocity is angular acceleration alpha. Thus, alpha equals to d omega by dt.